Hi everybody, my name is Alexander Jacob and today I'm presenting you the SAR2CUBE project. This project is being co-developed by EURAC Research and DARIS Technologies and funded through ESA. In this project we are developing a data cube software specifically for managing SAR data and making the use of SAR data simpler. We are targeting specifically backscatter data and also interferometric products like the coherence or interferograms, as you can see in the examples on this cover slide. The project has been designed to tackle this data cube from two perspectives, from the data generator perspective and also from the user perspective. From the data generation perspective, we want to look into how to best preprocess the data and up to which level in order to find a compromise between the flexibility of the user and how much it actually costs to store the data. So we have defined different levels of preprocessing there. Basically level 0, which is just the original SLC data and in radar geometry. Level 1, which we define as the SLC data in radar geometry, where you can also apply filters like different numbers of looks and so on. Or level 2, which in our case would then be the geographical referenced data as in a geoprojection. From the application side, we have then also three different use cases in order to tackle those. So we will try to apply our methodology using PSI analysis in use case 1, land cover mapping in use case 2, and change detection in use case 3. All of these use different kinds of input data in order to use all the different spectra of data that are available in SAR. So for PSI, of course, we use interferometric phases. For the land cover data, we are actually working with interferometric coherence amplitudes. And for the change detection, we will work with backscatter data. And then in order to access the data from the client perspective, we are implementing all of this based on the OpenEO interface, a new API, which is making it easier to do the processing basically. And for this, we are also developing specific processes for OpenEO that make the handling of SAR data easier. And this is exactly this OTF interfaces. For giving an example of how we create these data cubes, I show now an example of a classic processing chain for backscatter. So what you see here is a snap process graph that basically just takes an image, gets the precise orbit information, does the calibration and the spectral filter, and finally gives you a geocoded image that you can work with. In a similar workflow, if we do coherence, of course, we need to co-register two images and have a little bit longer process graph. But what we can already see is that parts of the process graph are actually the same. For example, this first part here. And more importantly, even if we work with backscattered images, we probably always want to work also not just with single images, but with a series. So basically, the first block here becomes our, let's say, level 0 data product. And then if we apply more steps, then we can enhance our data cube further. What you can also see is that this is all a graph, which is actually nice. OpenEO is another software that I mentioned earlier already that we want to use and implement. And as you can see, also here we have graphs. These graphs are much longer. I don't want to go into much detail here, but we can do complex calculations here, which can also be represented just by mathematical formulas. This depends actually a lot on the clients that we use. As you can see on this architecture overview, there are three different clients available: Python clients, the R client, and the JavaScript clients, which are all interacting via OpenEO with the backend. In this case, through the OpenEO project, we had already developed a WCPS-based version on Rasterman, and now in the SAR2CUBE project, we are adding also the Open Data Cube to this with Dask as a parallelization framework. There's also a possibility to run user-defined functions in Docker containers for even more enhanced processing, and finally some pre-processing that is done on extra resources. Thanks a lot for your attention. You can get a lot more details during our live Q&A at FIAC, and I hope to see you all there.